This is the Advent of Code, Day 4 solution, and today we're helping up with camp cleanup. So our elves have been given sections of the camp to clean up, where each section is numbered. So our examples are numbers 1 through 9, but the input we get has larger numbers. And the elves are pairing up to try and work out where they've got overlapping assignments. So for example, this one here, where you've got one elf doing section 6, and one elf doing sections 4, 5, and 6, they would be overlapping, and specifically, one would be completely contained within the sections that the other elf's been assigned. So that's what we're looking for in the first part of this solution, is ranges that are completely contained within the other when we pair up the elves. So let's make a start with our input. I've started us off by loading the input file, and I've also commented the format that we're working with. So number-number gives us the section range that the first elf's been assigned to clean up, then a comma to separate the two, and then the section range that the second elf has been given. And those are the two ranges that we're looking for a complete overlap in. So let's start by breaking up those two ranges, and then we'll break down the ranges themselves so we've got numbers that we can compare against each other. So let's start with that split on the comma. So we'll map line by line. We need to start by unwrapping the line, because that's got a potential to error if it's not loaded correctly. And then we will split the line on comma, and that will give us back an iterator for all the results that were found by splitting on comma. So we'll collect that into a vector, and that can be our ranges, which is a vec of string. And then each of those we want to turn into a numeric range. So let's write a function that does that. We'll call that getRange, which will take an input of a string, and it will return us a range of i32, i32, so start and end of the range. Missed a colon there to separate out the type and the variable name. And then we can do this by, again, splitting on hyphen. So input.split on hyphen, and we want to collect that again into a vector, so we can reference the elements of it. And we'll do that as range ends vec of string. Good, and then we can return our two values. So the first value will be the first value in the vector, range ends, and that'll be a parse to get a number out, and we'll tell it that we want an i32, and unwrap any errors, and we want to do the same thing for the other end of the range. There we go. Let's use that up here. So now we can return getRange on ranges 0 and getRange on ranges 1. So the two different elves, and that will give us back our input as a vec of a two-level tuple. So the top level is the two elves, and then internally we've got their ranges. So it'll be i32, i32, and we can copy paste that. Then the next thing we want to be able to do is to compare those two ranges. So let's write a function that can do that. We'll call this isContained, which takes a left side of the range, or a left range to compare, and a right, which is also a range. And we want to define it this way so that we can call it either way round. So because the left elf could contain the right elf's work or the other way round, we want to be able to pass this either way rather than writing a one-way comparison. So here we will be returning left first value is greater than or equal to right first value, and left dot second value is less than or equal to right second value. So that checks whether left is contained inside right. And then we can use that to compute our puzzle answer. So we'll take our input and we will iterate over it and map its values, taking each pair of elves. And then we can check if isContained pair.0 pair.1, or isContained, and this is where we're flipping around and checking the other possible direction, pair.1 pair.0. So either direction we're checking whether the elf is doing the other elf's work. 1, otherwise 0. So if we have a match for this line, that's counting 1 towards the puzzle output. So we'll count it, otherwise we'll count 0, and then we can just sum these up. Just makes it easier to sum the booleans up. Then we can assign that to a variable, fully contained count, y32, and we can print that out. Contained count. Let's see what that gives us. Cargo run to run it, and it gives us a count of 538 for my puzzle. So let's check that on the website. Let's pop that in and see if it's right. And it is, good. So we can move on to part 2. So part 2 is asking us how many of these ranges overlap rather than being fully contained within each other. So that should be a fairly small change. Let's jump in and make that. Let's use our isContained as a starting point for our new function, which we'll call isOverlapping. And we want to check that the left list overlaps with the right list. And because these are ranges that don't have any gaps in them, we can do that by just checking whether the bottom end of the left range is inside the right range, or the top end of the left range is inside the right range, which covers almost all cases. So let's start by doing that. So we'll say left starting is greater than right starting, and left starting is less than right end. So the start of the left list is inside the right list, or the right or left end at the right hand side is inside the right end on the left, and the left top is also less than right 1. So this is saying, is one end of the left contained within the right hand side? And this is almost correct, but we have a special case where the left could completely contain the right, and then neither end of the left list would be inside the right range. So we should also check whether the right is contained inside the left. So let's wrap this. So if that's true, and is contained, sorry, could be either case. And that will be right inside the left list. And then we can copy our map from last time. It's almost the same logic. So we'll call that our overlapping count. Overlapping count. And we'll print that out. And then we need to call isOverlapping in here. Let's get rid of the second call. IsOverlapping. Alright, let's try and run that. Let's cargo run the project to see what we get. And we get an overlapping count of 792. So let's put that into the website and see if that's the right answer. So let's pop that in. And that's right. So, fairly friendly day 4 challenge. I will see you tomorrow for day 5.